Welcome back to Dam and Museums 2022. To moderate this session, please welcome Neal Bilow, the CEO of Terentia.
Thanks, Tom. I really appreciate that. Good afternoon, good morning to some, and good evening, and even good night for all of those around the world. I'm happy today to be here at the conference and sharing our TechLab Spotlight Special with the Computer History Museum, one of our great partners here at Terentia. Today we're going to talk about something that's a hot topic for everybody, right? Everybody, it's the most common question that we get asked as a vendor, which is, what capabilities do we have with AI and machine learning, or what are we learning from it, from our experiences? And so I thought, who better to really talk about that today than actually the Computer History Museum, who've just completed a study on exactly this. And so let's get into it. Just to start a little bit, before we begin, I just do want to do a land acknowledgement. Terentia in Toronto, where we're based, just wants to acknowledge that our work and the work of some of our community partners takes place on the Dish with One Spoon territory. The Dish with One Spoon is a treaty between the Anishinaabe, the Mississaugas, and the Haudenosaunee that bound them to share the territory and protect the land. I do hope I pronounced those names properly. So let's start with a second about who's this guy? Who's me? Well, as I said, I'm the founder and CEO of Terentia, this new cloud native DAM platform built for the cultural sector. I have a dog. That was her first ever Puppuccino. I like Lego, and I'm pretty sure they made this guy after David Lipsey, our chair today. I'm pretty sure that's him in Lego form. I really miss travel, but I've really enjoyed time with my family over during the pandemic. At Terentia, we believe in empowering institutions to manage their data, develop insights, and really tell some compelling stories. And so you saw during the UHHM keynote, we were very happy to see that Martha used a bit of our vision of what we think both our digital asset management and our collections management system should be doing for us, the ability to help us manage, discover, engage, and trade. And today we're going to be talking a lot about the discover and engage. We also believe in environmental sustainability, which is why we partnered with Microsoft. And this allows us to work with you and them to help create a path towards carbon negativity with Azure and supporting that path, something extremely important for us when we decided to start Terentia not too long ago. And so our approach, as you're hearing, is a lot of collaborative and community development, both on our product, but also on greater learning activities and resources. If you go to our booth, in fact, today, you can register to be part of a DAM capability model workshop. I'm going to be led by David Lipsey. We'll be doing that in March. So if you head over there after our presentation, you can sign up for this as well. But we believe collaboration is really essential between a vendor and its community that it serves to build some solid, strong common understandings. It gives us an ability to focus on the problems and create good use cases, break away from that traditional model. Let's explore, let's test, let's iterate. And you've probably heard that as well today if anybody listened in on the Moats presentation. And that's exactly what we're doing again with Massimo Petrozzi from the Computer History Museum, somebody who's I'm really happy to be presenting today. Massimo is not only the senior audio, video, and digital archivist at the Computer History, but he's also the oral history program coordinator, wears many hats. Massimo's got a PhD in history of science, medicine, and technology at Johns Hopkins University, master in information studies at the University of Maryland in College Park. And when he's not preserving digital files, we always talk about new vegan food and playing music. Massimo, you ready?
Hi, Neal. Thank you so much. Yes, very happy to be
Excellent.
here to talk about this experiment that we did at the Computer History Museum.
All right, over to you, Massimo.
Thank you. So first of all, obviously, I want to acknowledge the contribution that the Institute of Museum and Library Services, IMLS, provided to CHM to complete this study. And so it was a very important aspect of this experimentation. Next slide, Neal, please. So briefly, what I want to talk about today is give you a very brief introduction of the Computer History Museum, and then a background on why we did this, and then what actually we did with the kind of approach that we had to engage with the machine cognitive services, and then at the end what we learn. And then if there is like Q&A, we'll be happy to answer some question about this. Next slide, Neal, please. So the Computer History Museum, you know, after 2 years of pandemic, has been open and not open. It's been obviously 2 difficult years for as any other cultural institution. We are located in Mountain View. And we have basically the largest hardware collection, and Mountain View obviously is kind of in the heart of the Silicon Valley. Next slide, please. Maybe more people don't know is that actually the museum is born a long time ago and on the East Coast. The founder is Gordon Bell, a name that is kind of one of the giant of the history of computing. And an important aspect is started inside DEC. A very important computer company located on the East Coast in Massachusetts. And then in 1984, kind of the museum became his own entity and he moved to Boston. I want to just underscore a few things here that are not they're kind of something that is always important to keep in mind when we talk about providing access to collection. The first one, it's kind of the history of the Computer History Museum define also why we have specific things in our collection. As I said, the history of the museum is very deeply intertwined with the history of DEC, and that explains why we have the largest collection of artifacts related to DEC right now. Also, one thing that is important, as you can read on this slide, Gordon Bell started his museum in an emergency rescue mode, basically going into the dump and trying to recover all computers that people thought that, you know, they were ready to go to the trash. And so I always like to underscore this tension between the computer as a tool of innovation versus a computer as an historical artifact, and how much kind of the computer industry, Silicon Valley, there's this tension between looking at the future and forgetting the past. And so when we talk about Computer History Museum, is always important to understand is like history of going from this emergency rescue phase into a more thoughtful kind of preservation access phase. And, you know, kind of is always important to understand the origins of your collection, because obviously your collection shape the way in which you preserve it and provide access to. Next slide, Neal. And that again, here there are like some numbers about our collection. It's a very large collection. As I said, you know, we're around like 42,000 actual physical object. We have historical software. We have papers and archival collection and assets. And we have a large moving image and audio collection. And what Neal was saying, I'm the oral history program coordinator. The oral history program is a very important program for us, because obviously is what just mentioning about the tension about the future and the past, especially when you're dealing with like most recent history. Often the preservation of that history passed via kind of of stories, capturing stories of people that were involved in that development. And so right now we have more than 1,000 oral history in our collection, and our oral history, they're all, most of them, I will say more than 90% of our oral history are video, captured via video, and we have also a smaller section that are just audio. All of them kind of can be accessed via video or transcription. Next slide, please. So what I was saying about kind of the different phases in which the museum went through, and based on the nature of what we are collecting, we are in a moment in which we really wanna kind of use new technology to open up our collection to a larger audience. And so the reason why we decided to experiment with the cognitive services was, first of all, because as Neal was saying, it's right now machine learning and cognitive services are a really hot topic, especially when we talk about providing access to archive. We know archives, they always struggle to kind of processing their own collection. And so there are always large backlogs and not enough archivists to kind of process everything we have in our archives. And so cultural institutions are start looking into machine learning and cognitive services to see if this technology can help us to process and provide access to these assets. And so a lot of the case studies that we engage with, we notice that often they happen in the large institution, and with often sometimes the computer science department behind them. And so resources that not every cultural institution have available. But right now, we know that cognitive services are getting more and more available. They're kind of, you can take out of the box kind of machine learning services and run them against your collection. And so we decided to see actually what happened if you just take some cognitive services out of the box without any training, you just implement it and you run them against your collection, how much they are helpful, how much metadata they capture, and how much those metadata are going to be helpful for user to discover your collection. The second reason we did it is like, if your name is Computer History Museum, I feel like it's your duty to experiment, especially with tools that are connected to computers. And so that was kind of a very easy choice for us to do, and kind of became an institution that and try to experiment with the latest technology to see if that technology can help you solve problems that affected other cultural institutions. As I said, kind of we were trying to figure out if machine learning can solve problems that are kind of affecting archives and cultural institutions in general since the beginning, I will say. So can machine learning capture metadata that they are helpful for people to discover and search your collection? And also something that right now we kind of rely on curators, on expert or historians, is trying to find connection among assets. Sometimes it's not always easy to capture that when you catalog actually the assets, or when you receive an asset, when you acquire an assets into your collection. And so we were wondering if the machine learning can help you design this network that often exists among assets, and that is not always easy to make that available and visible to users. And then there are like specific challenges related to AV material. You know, when you catalog and process artifacts, or when you go through a box of papers, you can skim through a piece of paper, or you can skim through a manuscript, and you can kind of capture very crucial metadata about the object, the title, the date, the author. Maybe there is an abstract at the beginning of the book. look, you know, attached to a 3D object. Sometimes you get the manual, so you can get some metadata really quickly about those kind of assets. For AV, the situation is a little different. Often there is not enough metadata. A title that you can read on a tape can be extremely misleading, not very clear about what actually the tape contains. Sometimes you receive tapes that have been used several times, so maybe the title that you see on the tape is not actually what is being recorded on the tape, because someone recorded over the original content. But also you don't have enough archivists to just sit in front of a computer and watch a tape, watch 2 hours, 3 hours, 4 hours, half an hour, whatever it is the tape. We have too many tapes to actually ask anybody to go through them and extract important metadata out of it. And that's where the machine learning comes in. You can process a video and hope that the machine learning gonna extract important information. It can recognize faces, it can read text into a frame, it can capture the audio, it can transcribe an audio, and then you can do keyword search. So there are ways in which the cognitive service can help in processing specifically AV material. And obviously the IMLS grant was an important push for us to kind of engage with this challenge. Next slide, Neil, please. Yes, so that's what actually we did. We, as you saw, our collection is pretty large, so we could not run all the cognitive services against the entire collection. So we decided to select a group of video. We specifically focus on our oral histories. The reason is that our oral history are probably the AV material that's the most robust metadata. We, as I mentioned already, we transcribe every oral history that we recorded. So that that means that for all, excuse me, for all the 62 videos that we selected, we have like the transcript that are being already edited, and so we have we could actually do a QC of the transcription that the machine learning was going to create. The way in which we choose the oral histories is that we kind of focus on two main topics. One is the history of Xerox PARC, a very important institution that we are focusing a lot in our collection. And the second one is in general the history of artificial intelligence, and that was kind of the idea of running machine learning services against the history of them. So that was kind of an internal joke for us. And also we chose we try to have a diversity of content in terms of like gender, race, sexual orientation, and obviously language, because we know that there are some limitation about the quality of the transcription based on the accent of the speakers. Not sure how well we'll do on my accent, so we try to test the machine learning on this. The remaining assets that we run were audio files, still images, and documents. Most of them were the transcript of the oral history that were identified that were connected to these two topics, just to kind of see also how the machine learning will help again see and highlight connection that link the oral history with the object that we have in our collection. The steps that we went through to create our prototype was obviously kind of brainstorming about the requirement that we want to see into the prototype, the kind of functionality that we wanted to implement it into the prototype, and start kind of discussing early wireframes. We then reach out to a third-party software developer And then we evaluate the prototype both internally and externally. We engage with some external user to see how they felt about the metadata generated by the machine, and then we kind of regroup and we discuss the lesson learned. If you want to know more about this entire process, the Computer History Museum is going to run a webinar February 28th at 11 a.m. Pacific time. Right now, the page of the event is already up on our website, computerhistory.org. So feel free to go there and register for the event. It's going to be an hour-long kind of webinar. We're also going to provide a demo of the prototype that we created here. I'm just going to show a couple of screenshots just to give you a sense of what we did and the lesson that we learned. But if you want to kind of have more information and details about the entire process, absolutely go and register for the webinar. Next slide, Neal, please. So this is for Neal. There's a dog, and we know that Neal loves dog. But the main point that I want to do here is that as you're gonna see, the prototype was kind of what the outcome of this grant was, basically a website. Right. But I want to underscore how much the lesson that we learn are really shaping the way in which we are thinking. Also, the back end right now, how we're implementing our own DEM, the kind of workflow. And so I just want to underscore this, that while the grant kind of was a front end oriented grant, the lessons that we learn are really helpful right now for us to also discuss how we want to implement machine learning on our back end. Next slide, Neal. Thank you. So what you see here is kind of the prototype page, and here is an example of what you will see if you do a search on demo. The Alto system search. You can see a picture on the bottom right of your screen. Again, a machine developed by the Xero Park. And here what you see is that you retrieve a lot of video because we have a lot of oral history, obviously, based on our selection. You see the transcript and you see the images. The first thing that I want to underscore is that when we thought about the prototype, kind of the UI, UX consideration were not our priorities. What we were really trying to do is to kind of really understand how much commercial machine learning services will help us to create metadata and process your collection. And so you see it's a very minimalistic kind of approach to the UI, can be obviously enormously improved, but I just want to clarify the UI was not our main concern here. So what the prototype gives is like a user interface to kind of engage with the cognitive service. And what you do when you do a search, you query an Azure SQL database where the database contains the metadata extracted by the machine learning the cognitive services, and then the metadata are obviously also into the Azure storage container where the actual assets are stored. What we use for processing our assets, for the video files, we use the video indexer from Azure. For the files, the PDF, we use the text analytic, and for the images, we use the image analytics. For the audio, what we did, we create a transcript, and I'm going to show you later how you interact with the transcript. And then we extract keywords, topics, and people. For the PDF, we extract key phrases, kind of topics, organization, people, and location. Instead, for the images, we just extract tags and kind of if they kind of peoples and organization. Next slide, Neal, please. What you see here is what happened when you then select a specific video. Here you are seeing the video of Bob McAfee, and here on the bottom of the video you see the different kind of metadata extracted by the machine learning after processing, and then on your right you see the transcript. The image on the left, it shows you just like when you open the video. The image on the left is to show you, if you see at the beginning on the top corner on the right, you see a word in bold and underline. The word is Ethernet. Is when you search a specific keywords that the machine learning found it into the video, you obviously click it, and you the video will go straight to that point, and you can actually listen and view the video when it talks about the Ethernet. Again, it's a very basic UI kind of interface, and also you see how the cognitive services kind of break down the transcript every few seconds. Kind of that's the nature of the video indexer. It's clearly kind of being developed for kind of a different kind of services. They more kind of customer services when you interact with a bot, or you talk on the phone with this computer, and you try to go through and get to a real human being to solve your internet issue connectivity. So that's why kind of the way in which the transcript is presented right here, and obviously you can change that view, but I think it was also important to show what is the kind of the main use of these cognitive services. Next slide, please, Neal. And here you're gonna see what happened when you translate, and really the translation was like a very crucial aspect of what we learned. Here you see on your left the Mandarin, and on your right the Spanish translation. Next slide, Neal. I want to just show that also we did the translation. You see on the bottom what happened with the translation on your transcript. I want to jump, Neal, next slide, please. I want to just give you an overview of what we learn. We learn one thing that I want to clarify is that a user that tested this will not access the human generated metadata. All the metadata they were able to engage with were generated by machine learning. And so what we find out is that while translation and transcription were extremely helpful, actually the quality of the transcription and the translation was really surprisingly high. We were not expecting that quality. Regarding the other question like tagging images, some of the recognition of keywords, etc., we are not there yet. And obviously the human curator metadata are still better than the machine learning created. But you can see that in the future, you know, a hybrid approach might be really helpful. The last thing that I want to say is that we did not train the results. So this is this is what you get out of the box. And obviously, the more you're going to train this machine learning algorithm, the better the result is going to be. And so again, the idea of having an hybrid approach, probably training the machine will provide better metadata, better tagging, and better keywords. And the last thing I want to say that in some cases, still the machine learning was able to highlight those connections among assets that we were really interested to see if it was able. So this is really promising, and I think that the hybrid approach and be able to training the cognitive services will increase this ability. And so this was really a promising experiment. And that's it.
I'm going to actually stop sharing, Massimo, and just come back for just the two of us to say thank you for really such an amazing presentation. today.
Thank you.
I know that there was a lot of people who wanted to ask questions. In the chat, there was a lot of people asking about the presentation. Hit us up in the exhibition space or send me an email. You can find me pretty easily, and we'll gladly help share the presentation. Don't forget about Massimo and the Computer History Museum's webinar as well, where they're going to go really deeply into this. I also think there's a blog post coming out. Paula from the CHM may have also posted that in the comments today as well. Massimo, as always, I love
you so
partnering
much.
with you.
It was
and
a
the
pleasure.
Computer
Sorry I
History
went like a
Museum.
little too long.
Don't even think about it, Massimo. This is great. For those who are still on, two things. One, don't forget to visit the exhibition spaces. And two, the Birds of the Feather tables are open or about to open soon. A lot of really great stuff on workflows, integrations. I think Christy from Ingenium is going to be talking about what to do next after her great presentation. I think the Moat will be there, maybe even a few others. We hope you enjoy the day, and thank you to Henry Stewart for putting on such an amazing event once again. And thank you again, Massimo.
Thank you.
All right, talk to you later. Bye-bye.
Bye-bye.